Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap. I am so excited about this conversation we're going to be having here. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the conversation, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience, although I will warn you, with 6 panelists, we probably won't have a lot of time for question and answer period. But if you do have a question, go ahead and send it on in. Just use your GoToWebinar control panel and click on the questions button and submit your questions. And at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. Okay, with that, let's kick off today's webinar, which is managing the application security tool stack. As you can see on your screen, we have 6 very, very smart people joining me today to talk about the topic of managing the application security tool stack. We have, first of all, we have Jeffrey Martin. Wave, Jeff, Senior Director of Product at WhiteSource. And we have Prakash Linga, who is the CEO of Blue Bracket. Prakash?
Hello.
We have Christian Vanden Branden, who is the Senior Vice President of Engineering at Zero North. Hi, Christian.
How are you?
Good. We also have Pankaj Gupta, who is the Senior Director of Marketing at Citrix. Pankaj?
Hello.
And Jonathan Knudsen, who is the Senior Security Strategist at Synopsys.
Hi there.
Hello, and then finally we have Alfred Chung, who's the Senior Product Manager at Signal Sciences. Hi, Alfred.
Hello.
I am so glad you guys have decided to join me today for this panel webinar. Like I said, we're going to have a great discussion. We have so many great topics and so many thoughts rolling around with the collective intelligence here. So I'm really thrilled to just kick off today's webinar. The conversation that we're about to have is loosely based on an ebook of the same name that has just been published, and we're going to be sending out the links a couple times during today's webinar. We'll send out a link to you guys so you can download the webinar, or sorry, the ebook. We're also going to be in the follow-up email after today's webinar. We'll be including the link in that as well. So without further ado, I'm going to go ahead and just stop showing this title screen, and we will just have our faces on, because I think that makes for a much more conversational event, and also kind of gives the audience a little better view of actually who's speaking when. So I want to just kind of kick things off by talking about that symbiotic relationship between developers and security teams, and I call it symbiotic, but it hasn't always been that way, and really, truth be told, it's probably not as symbiotic as it really should be. We are making progress, but some might argue that it's not enough progress, not quickly enough. I know we did have Jonathan, there was a Synopsys survey that you guys put out not too long ago, and said that 48% of respondents said that they consciously push code out with vulnerabilities into production because of time constraints. So, I mean, obviously that needs to get better. But I do want to kind of kick off the conversation that we're going to have, talking a little bit about that relationship between security teams and developers. So, just I don't know, just let's start by just kind of maybe noodling how maybe developers and security folks can work together better or best.
Sure. So, as you say, it's not always been as symbiotic as it could be, and another polite word for that is friction. I'm sure you've heard that one, and that there are other less polite words for it. But we're at a really interesting time right now with regard to application security, because there are sort of two universes that are sort of colliding together, and the one is what you're talking about it's been called shift left, where it's this idea that instead of doing all the dev and then doing all the security after that, we're sort of sliding security leftward into the process so that it becomes part of the process. And then the other universe that's colliding is this whole DevOps movement, which is really another take on development methodology, and emphasizes speed to market and emphasizes automation, and emphasizes a culture of continuously looking at your process and improving it. And so the way that works with security shifting left is it's the idea that as you're doing your software development, you've integrated and you've automated security testing so that from the developer point of view, really not much has changed. So in the old world, the developer did this dance every day where, take a ticket from Jira, write some code, put it back in the SCM, rinse and repeat, and do that all day long. The Jira is the source of truth about what to do and so forth. And in the new world, if you're doing it right, if you automate the security tooling and you integrate it properly, it's pretty much the same story for the developer. Now they've got security test results showing up in the Jira, but it's still the same process. Pull a ticket, do some work, put it back, and go on like that.
It is absolutely about the speed, and we need SecOps at DevOps speed. And if you want a SecOps and at DevOps speed, then security has to be a shared responsibility between the developer, organization, DevOps, and security. And they have actually the common goals of really looking forward for automation, continuous delivery, security, and agility. And as long as security is seen as a friction point, DevOps and operations team can find creative ways to avoid that friction so they can ensure the continuous delivery. There are few early best practices, like including the tools like scanners, runtime agents into the DevOps automation tools and workflows, which are already happening, looking into security policies that can be automatically deployed based on metadata as tags and automation. And observability is also a big part that the same tools with DevOps team is using for observability and orchestration, they should be available to security team also. But there is a much bigger fundamental shift, which is a cultural shift. Taking security as the first principle and really driving that security being the first principle, that's the cultural shift. And cultural shifts is not easy, and that's the reason we are having that discussion today.
Yeah, if the culture goes, that everything else follows it, right? So fundamentally, when you stop thinking of it as an us versus them, and you start thinking of it as just us, you find the solutions and the creative points. Culture comes first, the process comes afterwards.
Totally, right? And so that's where I like to think of this as security at the speed of code, at the speed of development, right? So in the past, what I have seen across many organizations is security teams work in a silo, right? Build sort of the set of sort of debt that's collected over time, and development teams are working hard and trying to pay off that debt, and it's very, very difficult to close that gap, right? And that's where that cultural shift that we're talking about, right, is all about more looking at continuous monitoring and remediation, right, through techniques and tools like continuous integration, continuous deployment of the CI/CD pipeline. But equally interestingly, allowing and enabling developers to use these tools on their machines, just like every developer uses a linter, right, and it's part of their build process. It also runs on the CI/CD pipeline. Same thing, if they're looking at trying to find open source vulnerabilities or secrets in code, right, they're able to run that on their machine, find things early before they check code in, right, is the cultural shift that we're all excited about.
It is not building the bridges between the teams. It is removing the boundaries between the teams.
I agree with that. And part of the way to make this part of the culture is really to include security requirements as part of the definition of done. So having run scans, having resolved the proper level of vulnerability, but also important to be able to give continuous visibility to security by, as several of you pointed out, by having orchestration and automation so that right from the first day of your first sprint, you're able to run scans and you're able to discover vulnerabilities.
Now, there's been a long-standing myth that developers don't care about security, and I don't think that's necessarily true. Of course, there are cultural differences and differences in terms of the priorities of security versus application developers, but sometimes it just starts as easily as just scheduling lunch and learns and just having one-on-ones and that kind of thing. And eventually, as you kind of get to a common agreement in terms of what your goals are when it comes to security, then that kind of plays out into tools and automation that kind of makes security easier to operationalize in the application development workflow.
All right, so one of the things it's been brought up is the idea of automation and bringing that into the workflow. And so I guess my question to you guys is, how does that actually impact the relationship between developers and the security teams? And not only that, but also that whole integration of security into the DevOps cycle. Where does IT automation or just automation in general, where does that fit in relation to those two things? Anyone?
I'll take it. I mean, to me, there's two big benefits to automation, right? One is speed. The other one is it actually does help, I find, with some of the cultural pieces, because it's very impersonal, for lack of a better word. It's one thing when you have a JIRA ticket assigned by some process. It's a different thing when Bill from security keeps rejecting all of your code. So it does actually help a little bit with some of the cultural change. But of course, look, automation, repeatable, quick processes, who doesn't like that?
Yeah, it's the repeatable part that I think is crucial, right? We used to have this model where the dev team pretty much finished up and handed it off to the security team, and they would run their tools, and it was all ad hoc. And who knows if they use the same configuration from one run to the next. And let's say your security person left and nobody knew how to run the tool and so forth. So a lot of it's about repeatability and just having it. It's like a set and forget. Like, okay, let's set up the pipeline. We'll get the automation going, and then stuff just shows up in the JIRA.
And many of the organizations deploy today tens of times a day, and some very large organizations even deploy hundreds of times a day. So security has to keep up with the speed of that new code development, deployment, and releases. And only way it's going to happen is through a cultural shift, and that cultural shift also driving the automation. If you don't have automation, you can't do tens or hundreds of releases in a day. And most of the teams are also being measured today in that how many releases they do in a day or a week or in a month. That's a KPI. You see those numbers in people's resume that I empowered that many releases in a day. It's a new KPI. And that KPI is built on the foundation of cultural shift and automation.
Totally. For me, that's the DevSecOps mindset, right? Where bringing together the three teams to enable that automation in the context of, let's say, a CI/CD pipeline. But it's critical that developers are have the same set of tools available, right? So if security is evaluating success different from how developers are working through their workflow, then the incentives are not aligned, right? And so as part of that, right, so I want to reemphasize that it's not enough to just focus on just the pipeline or some of these automation further away from what the developer is working on, right? And that idea of shift left and what they do on a day-to-day basis, it's important to automate that aspect as well. So that way they tend to find and fix things early.
Yeah, I agree. And I would also say that it's important as issues are discovered to very quickly prioritize and refine them to a point where developers know which one to focus on, right? Because you can easily get dozens, if not hundreds of vulnerabilities. And as you're trying to close your sprint goals or you're trying to push code to production, the ability to really understand which one need to be fixed is very important.
Excellent. Excellent. Well, let's switch gears a little bit and talk about open source security. It's widely known that open source technology in general, open source code is being more widely used as organizations are looking to cut costs and increase their velocity. But open source is also kind of known for vulnerabilities because of any number of issues, from code not being updated to just the fact that anybody can contribute to open source code. So Jeffrey, I want to kind of ping you and ask you where you kind of see security fitting into the the open source conversation, and how organizations might be able to still utilize open source code and have still secure applications. So
Sure.
what are your thoughts there? Start us off.
So it's funny, actually. I think it ties in very deeply to what Christian just said, because it's one, you have to know what you have, but two, you have to prioritize your vulnerabilities. And open source, by its very nature, is open about its vulnerabilities. They're published, which means everybody knows about it, which means it's a primary attack surface. Because it has a bunch of disclosed public vulnerabilities, and nobody's great about keeping their open source use up to date. So if you're not really regimented and very process driven on making sure you know which vulnerabilities you have and updating the libraries very, very frequently, you have them. And it's a primary attack surface. So a lot of people prioritize their open source vulnerabilities above their proprietary ones, simply because more people know about them. So I think it's interesting. I don't know, does anybody disagree with me on that prioritization? Or I don't normally ask people to disagree with me, but I'm just curious.
I think it's spot on, right? I mean, just the knowledge of the vulnerability make it, like you said, a primary attack vector, and it's closing those is important. More important is to have, as you pointed out yourself, have a very good process about refreshing those library constantly, knowing the state of the new library as quickly as possible, so that you minimize the risk.
Yeah, and it's not just the vulnerabilities, right? It's the availability of exploits and the exploit maturity, which I think totally tilts the game towards what you just pointed out. The fact that open source is out there and people have the time and energies and gets the kind of looks where right, some of these exploits are put together, and having these exploits available is what makes that be the #1 threat that's probably exploited.
But who actually owns it, though, at the end of the day? Because we're talking about open source code, it's it doesn't really have an owner per se. So who takes on that responsibility, and whose responsibility should it be?
I think that something very important earlier on, which is that, and I think it was Pankaj, but there's a shared responsibility model. So it's both the development team, because they're delivering code, they're choosing to incorporate a library, therefore they are accountable for the security. At the same time, not every developer, not every engineer is knowledgeable enough about those things. So your security team needs to provide the right guidance to those guys, and needs to provide the right policies so that they can implement them in their pipeline.
Something we're hearing a lot organizationally is the idea of a security champion, which is somebody that's inside dev that has a little more knowledge about security and can sort of serve as the emissary of the security team inside dev.
I would say security also needs visibility into those processes, and ensures that those checks are occurring, and auditing the policies and making sure that they're being enforced, right?
Totally, and not just open source in particular, right? So I think for security teams, it's important to know their code in the organization, right? Where did it really originate from? How much of it was written by their developers, right? Versus borrowed over from Stack Overflow or some other potentially copyleft licenses, right? Or use open source libraries, right? And all of that happens pretty routinely in organizations, right? And from that, understanding the risk profile, right, is also a big part of mitigating the risk from open source, both the license risk and the business risk, but also the vulnerability risk.
And I think it's even getting a little bit worse, because more and more open source is being used in our infrastructure, not just in our applications.
So is it really that much more vulnerable? Is open source code really that much more vulnerable than other code, or is that a fallacy?
No, there's really nothing good or bad about open source code as compared to anybody else's code. It's just code, and there are good projects and bad projects, and so it's something that everybody uses, right? Like nobody builds an application from the ground up. So everybody's pulling in open source projects for little chunks of functionality that they need, and which is fine, and it really helps with time to market. And some of these projects are really, really good and a lot better than you could write if you tried it yourself in, 4 or 5 years. It's just a matter of, it's software, it's got vulnerabilities, it's got stuff. It just needs to be managed properly as part of the process.
I think fundamentally you find more of the vulnerabilities in open source just because you got more eyeballs on it.
Mm-hmm.
That doesn't mean the code is less or more secure, but it does mean, I think, in general, for most projects, especially the big ones, open source might be a little bit more secure in that you have more people looking at it. They find those vulnerabilities. The problem is those vulnerabilities are immediately public, so they're also higher impact vulnerabilities when you find them. But I mean, look, if you have a lot of people looking for vulnerabilities, you're going to find them.
And I think that's true. There are two parts of it. As Jeffrey talked about, there is certainly more transparency about the vulnerabilities of the open source code, but there is also a little bit opaqueness of that. What is the roadmap to get it fixed, and who is going to fix it? And that's where the community really comes into the play, that how active the open source community is to fix that. The reality of open source community, I did a survey some time back, most of the open source projects, they are only top 10 developers who are doing 70 to 80% of the code. So when it comes in their priority, but I think that open source community model has to evolve a little bit more, that in that community, if there are few champions that who continuously focus and looking into the vulnerabilities and fixing that, open source code will benefit tremendously. But absolutely, more transparency is there, but community has to stand up to fix that faster. It is not just the work of top 5 or 10 super contributors.
All right. So it truly is a community effort then. So, all right. Let's see. So, yeah, along with open source, we're now seeing kind of this emergence of the idea of infrastructure as code, and that is becoming more a common conversation among IT organizations. For a number of reasons. Streamlining operations. Hopefully increasing security, but there are also definitely some considerations security-wise that need to be considered when thinking about infrastructure as code. So, Prakash, I wanted to ask you, how does infrastructure as code actually change the security landscape when we're talking about application security? I mean, are there different considerations that need to be thought out before an organization decides to dive into infrastructure as code?
So it's pretty fascinating when what code is today, right? It goes way beyond applications, as we know it, and what's considered code has changed heavily as well, right? So if you'd asked me about maybe 5-10 years ago, I wouldn't have considered YAML files as code, right? They're configuration files closer to XML, right? But that's what most of infrastructure as code is today, right? So what code has now become is like a net new attack surface into your enterprise, right? Not just impacting the applications that you develop, but also impacting some of the other critical enterprise systems, right? And so we talked about open source and some of these code vulnerabilities, right? But there are many others. A good example is secrets in code, right? And credentials continue to be the primary threat vector into an enterprise, right? So 50% of all breaches happen because of credential loss of theft, right? And GitLab, one of the 3 big Git providers, right, published a stat which says something like 18% of their projects have secrets in the repositories, right, that they host. So it's that widely prevalent, right? It's not just secrets in code, but developers optimize for the speed of innovation, the speed of code, right? And inadvertently, check their, project files in, right? PII, PHI information into code, right? Many times there are misconfigurations, right? Whether it's Helm misconfigurations or Terraform or other kinds of infrastructure and code misconfigurations, right? And quite often there is very interesting information about what the infrastructure network architecture looks like, some internal IP addresses, URLs, right? And all of that is, like a hacker's paradise, right? Especially when this information makes it into public repos. Unfortunately, happens way too often. Right? This again, developers, right? Sometimes they're passionate about their work. They save that code, and that code makes the public repos. Sometimes inadvertently they make a private repo public, right? Or they host code as part of a website, and that .git folder is available publicly. All of these happen often. They're part of some very widely published recent attacks, right? So all of this is kind of unique for infrastructure as code. It's kind of unique to the world of microservices that we live in, right? And which effectively brings me to the fact that application security has to be rethought in a more holistic fashion, right? And we discussed briefly about code governance, right? Understanding what code there is, who has access to it, who is accessing it, particularly very critical with infrastructure as code. And not just who's accessing it, but who's executing these scripts, right? So in summary, right, so I think addressing these new threats should be a priority for application security and DevSecOps engineers, in addition to some of the traditional aspects around vulnerabilities that we discussed earlier.
So do we need to have maybe change the discussion from application security to code security? I mean, does that do we need to change our mindset when it comes to that, rather than look at it more from an from a general code perspective rather than just an application perspective and how they interact with each other?
I think we just need to broaden it out so that we make sure that we're talking about the entire development lifecycle. So with AppSec tooling, we spend a lot of time thinking about the implement and test phases of the whole process, but that's not enough. Like, if you're going to do a secure software development lifecycle properly, it really is end to end. And so you start all the way back when the application is a twinkle in somebody's eye, and you're just doing the design and the architecture. Security's got to be top of mind while you're doing that. And then at the other end, when you're doing release and maintenance, you start thinking about these like packaging exercises. Like, if you're going to containerize this thing, or if you're going to deploy it somewhere, you have to be thinking about the security of where you deploy it and how you deploy it. And that gets into all of this, infrastructure as code types of things. So I think we really are still talking about application security, but we just have to make sure we're seeing the whole picture end to end in the process.
Yeah, it sort of boils down to everything's an application now. Honestly, it's kind of how I view it, right? It's not just, is it application security or code security? It's, look, all code serves an application type purpose for the most part nowadays. Infrastructure is now an application, which is a interesting complexity, but I'm not sure it's even all that different than it always was. It's just a more complex application now.
But that's the mindset shift, though. You can think of it as code compiled into application, and then you have to think about static, dynamic, and runtime analysis, right? It's really the entire life cycle of code, right? Starting from that initial, as Jonathan pointed out, right? The inception of the idea and the code that developers write, all the way to when it's deployed, right? And also, right, as we were discussing, right, there's now this emphasis around automation, right? Whether it's security automation or even like compliance as code, policies code, right? All of these are buzzwords today. But all it points to is the fact that, right, code automation is becoming central to how we think about not just security, but also how we build software, right? In a big way, right? And so that's where I think code security is a good holistic way to think about, right? Not just some of the traditional aspects around application security, but also, as we talked about, code governance in the earlier aspects, but also thinking about some of how these repositories may make it to the public world, in which case, right, right, that poses a net new set of threats that we don't traditionally think about in an application security view of the world, where you're working really with code from private repositories that are going through a set of steps that then can be built and deployed into either in an application or a service, right? And so as the scope expands, right now you're starting to think about some new set of threats. And a good example of a strategy is to try and monitor, right, public repositories, right, and look for code and secrets and other information from your enterprise that may make it to these public repositories, right? That's clearly way more risk, right? If you think about any of the threats we discussed, open source or otherwise, they become that much more effective. The code is right there for someone to look at and figure out what is the most effective exploit to use to find a way in, right? So I think in that sense, code security should be way more a holistic approach beyond application security.
I would say that one caveat to keep in mind, though, is that there are a lot of business critical applications out there that are no longer in active development. These legacy applications that you often see in large enterprises. Those two need to be protected, right? And there are times when people don't know where the code is, or the person that developed no longer works at the company, right? And in cases like that, code security may not be feasible.
Totally. So another aspect that is very common in this day and age is remote developers, right, and contractors, right? And that poses a set of challenges, right? Today, right, in the world of code, there aren't enough controls, right? It's hard to know if one of your remote developers contractor is no longer working at that firm, right? And most companies, what do? They do a periodic audit once in 6 months to figure out whether the person is still working, right, at the part of the contracting firm, and then they manually revoke access to that specific person, right? That manual audit doesn't scale. That poses a lot of these challenges, right? And that's where some of the automation beyond the CI/CD pipeline, trying to both set and enforce security best practices throughout the life cycle of code is, I think, extremely critical.
I think, Jonathan, you hit on it with security by design straight off the bat. And Prakash, you kind of highlighted another risk vector there, which is how you develop your application also determines a large chunk of your vulnerability surface, right? Not just architecture, but who's coding it for you, as you pointed out with contractors. And a lot of times people kind of forget those parts. But fundamentally, your infrastructure, you're dependent on other people, and that's usually part of your architecture. So it's important to think all of that out from the very, very beginning.
Yeah, that's a good point. I think when people first hear about security, they're like, oh, I understand. Developers write the code, and developers make mistakes. It's a security problem. So let's beat up on the developers until they do better, right? Or at least let's educate them and let's train them and so forth. And that's really not the point, right? The point is you have to improve the process that's around them so that, sure, they can learn, they can do better, they can know more about security, but you have to make the process around them work so that it catches stuff that they miss and lets them know, because they're good people, but they're just human. They're going to make mistakes.
It's basic supply chain management. It just happens to be software, and increasingly our infrastructure, which is also software.
Yep.
What about for cloud native architectures then? So, we've talked about infrastructure as code, but Pankaj, I want to bring you into the conversation and take a look at cloud native architectures and their implication on application security. Containers, Kubernetes, any other type of application or technology that is quote unquote cloud native. So how does that change the conversation?
Charlene, this is a great question, and we hear that many, many times from most of our customers. Many IT organizations are already planning or have already transitioned to microservices or cloud native based architecture. And the key reasons for them is the better agility, scale, faster release cycle, faster deployment cycles, and also portability. But before we go into specific to cloud native applications, we have to look at the forest before we look into the trees. So what I mean by looking at the forest, we have to look at holistically. Do I have a strategy for consistent security posture across my monoliths and microservices-based applications? There can't be two ships in the night. Do I have the same level of protection, same holistic level of protection across monoliths and microservices? That means if you are looking for more north-south, then web application firewall, bot management, always on, volumetric DDoS protection, API protection, they are just examples. So you have to look at very holistic protection. The third piece which you have to look at is really the operational consistency. Do I have the same DevOps tool integration for monoliths as well as the microservices-based application? Do I have a single pane of glass for observability across all of them? So the first piece is very, very critical for any DevOps or SecOps or cloud native organization or development, that am I looking at a consistent holistic view of monolith and cloud native versus two ships in the night? And that's where I see a lot of segmentation in strategy for many of the organizations. So that's where the SecOps team or the CISOs comes very strongly into that. The second piece is looking into the tree here. I think as this technology is evolving very fast, microservices-based applications have been protected extremely well for north-south traffic. That means the traffic bringing into the Kubernetes cluster into that. The biggest hindsight is how do I protect traffic between the microservices? And that is the biggest hindsight. This is the blind spot for many customers, that many of the deployments in the world today for microservices are not protected for east-west traffic. That is the traffic between the microservices. And I think the new emerging technologies like service mesh allow enterprises or organizations to protect that traffic. And there are a lot of new features coming up, like the mutual TLS, which allows us to protect from man-in-the-middle attack, having the encrypted service, because the world has already moved to encryption anyway. But many of these microservices who are talking to each other inside a cluster, that traffic may not be encrypted. So that's the first piece to look into that. Then making it very strong. Identity, authentication, authorization policies to be defined for all the east-west traffic. For example, you don't want your credit card processing microservice to communicating with your Office badge reader microservice. Somebody has to do that. Somebody has to implement that. But there are also challenges with that. This technology is so new. Service mesh, the biggest issue right now in the marketplace is the complexity. And that's the reason having the right skill set, the right talent is very, very critical. But a lot has to go into the simplification on microservices security environment. But almost every customer we talk to is aware of that. They have to fix it.
All right. Well, I mean, go ahead.
To this point, yeah, I think that to Pankaj's point, also the fact that in very aggressive DevOps environment, the team is responsible for delivering a microservice completely independently, right? And so you really put all the onus of security enforcement, of detection of vulnerabilities, of looking at the impact on the security architecture at the level of every team, and you don't want to get them because velocity is what matters today. And it's important to be able to really automate your security processes throughout your CI pipeline to achieve this.
Agree.
Excellent, excellent. I think we're still relatively early days as far as cloud native and security. So I have a feeling this is going to be a conversation that's going to be expanding as the months go by. So be interesting to kind of revisit this topic later on. You know, I think we have seen, I can tell you from coverage that we've done on Container Journal that the topic of container security is becoming a lot more popular on the site. So yeah, I think we're seeing some movement there, and I think as the technology is expanding and being embraced by more organizations, I think you know, that definitely it's becoming more top of mind for organizations, and just understanding the differences in security between cloud native architectures and you know, I dare I say it, the traditional IT premises, on-premises environments. So good stuff. I'm really excited to see how container security evolves, because as I said before, I think it's still pretty early days in that respect. So doing a quick time check, we are 20 minutes to the top of the hour, believe it or not. And I want to keep rolling on because we still have a couple more topics I want to get through. And the next one is this, for lack of a better term, I hate to use it, but next gen platform. So I'm looking at you, edge computing and API security and other kind of application security considerations or things to consider when we're talking about application security that don't maybe neatly fit into particular buckets. So Alfred, I want to tap you now. I want to talk a little bit about edge computing specifically and kind of the need for different security technologies. Again, different topologies, different technologies. So what are you seeing in the edge computing space as it pertains to application security, and what are some of the different considerations there?
Sure. So, you know, edge computing, I would say, you know, one of the primary goals of edge computing is to reduce latency and bandwidth, right? And that essentially means like running the application as close to the end user as possible. And with security, that also means having security as close to the end user as possible, because you don't want to introduce additional latency by, you know, forcing every request to go through some WAF that's hosted in AWS, because that would kind of defeat the purpose, right? I'd say that, you know, in terms of what I'm seeing is customers really starting to adopt like serverless platforms like PaaS, but also like serverless compute like Lambda. And as you see, these technologies are starting to be deployed more at the edge, at the points of presence, closer to the end user, again, with the goal of reducing latency and bandwidth. When you have these highly managed platforms like serverless compute, where customers don't have access to the underlying operating system, they don't have access to the underlying servers, et cetera. And again, they don't want to introduce latency. And of course, you know, you want to make sure that they are coding in a secure fashion and not introducing vulnerabilities at the code level. But at the same time, you know, we're in a world where, you know, things get missed, and ultimately you do have to have some runtime protection, right? Maybe because maybe the development team just wasn't you know, properly trained, or there was some open source library that was used and it was an older version, right? And you've got vulnerabilities in your application, and now that it's running at the edge and you don't have, you know, you don't want to put anything in front of it, right, to protect the application again, because you don't want to incur that latency hit. What we're seeing is customers adopting technologies like RASP and one-time application self-protection, essentially protections that you can deploy within the application itself at the code level to protect that application in case if, you know, there is a vulnerability, let's say, that was missed, and you want to do some protection against, you know, your OAuth POP 10 and that kind of thing.
Excellent, excellent. Anybody else have any thoughts on edge computing and the security, you know, to not maybe to lock down any of the applications that are running at the edge, or any of the technologies that are being used at the edge? I know it's a little more of a nascent topic, so you know, it's, I think right now it's almost a free-for-all, if you will. I hate to say that.
I think when we move to the edge security, the most important part really comes into two things. One is that how do I ensure consistent security posture? Do I have a centralized policy engine which I can make sure that when I make a changes, to one specific feature or one specific rule, does it propagate all across? So having a centralized policy engine, having a controller-based architecture, that's where the world is moving. But that also means that in a global organization or in this flat world, that the rules which you need for on-edge computing could be different in certain geography or certain markets or certain applications. You need a holistic policy definition, but also have a ability to granularly change for a specific subsections of that, especially when the technologies like 5G is coming up, which gives you virtualization and which gives you super micro segmentation into the network. You still need a consistent security policy, but you also need a very granular security policies for specific use cases or specific geography or specific environment. It's a tough problem to solve, but it comes with a lot of strategic thinking requirement and a better architecture design for that.
Yeah, that's what I was going to say. Just by the fact that edge is by definition distributed, everybody does put a little bit more thought into what data they're putting where. So in a way, it's actually a very good technology to almost force some really good, security practices and policies in general, because you really do have to think what data is where and how am I protecting it just to implement.
And you also, the other problem is that you cannot just focus on your delivery pipeline, because you may have done a great job at ensuring the security of an application. But if you push that to the edge to thousands and thousands of IoT devices, and then you discover a vulnerability later on that was not known, but is actually in the code of running on all those devices, you have very good processes for patching or updating those devices as quickly as possible. The loss of data, as you pointed out, that's a big risk, absolutely, and we need to be conscious of that. But there's also the fact that all those devices could be used for DDoS attacks or worse, right? So being able to patch those and maintain those is important, and that's a complex problem.
So, one of the things that I know edge computing uses, but other topologies or other methodologies use as well is APIs. And I know that's been a great help to kind of connect technologies together, but do they also introduce a level of vulnerability or maybe another attack vector, if you will? And what do organizations kind of need to keep in mind when they are utilizing APIs in their in their application stack?
Yeah, so take a look at the OWASP top 10 for API security. I'd say that's a pretty nice kind of primer on a lot of the challenges or vulnerabilities that developers unknowingly put into their APIs. And yeah, like it's APIs obviously are creating a lot of new use cases for end users, creating new integrations and conveniences for end users, but at the same time, they're probably making more information flow than is really necessary, and that's one of the concerns that's in the top 10. So I would definitely start there.
Yeah, absolutely. I think we spend a lot of time. I mean, it's pretty well understood now that if you're pulling in these third-party and open source components to build your application, that you have to manage those properly. And I think APIs is one of those things that's been moving faster than we can quite keep up with it. And so I think that's really an emerging area right now, where you look at your application and you really need to be also managing all the APIs that you're calling, and how are you authenticating them, and what if they're really trying to do something bad to you, and so forth. And likewise, flip it around, like almost everybody who writes an application nowadays is also exposing an API, and so you have to be looking at that both from a design and implementation standpoint to make sure that you are making it as low risk as you can.
You really have to understand your trust model, right? Of course, most APIs are internal, not external. But even just purely internal APIs, your application talking to itself, you have to understand how you're authenticating. You have to understand what you trust. You have to understand what category of data is being moved. And there's a few maturity models out there that are really helpful for this, but fundamentally, I think people generally aren't putting enough thought into the trust of their APIs.
All right. All right. Well, 10 minutes to the top of the hour, guys. This hour has flown by. But I know that we would be remiss if we did not include that age-old argument about whether to go with one particular vendor for a multitude of security technologies, or to kind of do a multi-vendor approach. So, Christian, I want to bring you in because we haven't tapped you yet. So, what are your thoughts on a single vendor approach versus a multi-vendor approach to application security?
So we talked about the fact that the process of ensuring application security is complex. That you cannot just look at the code of the application itself, but also the code that describes the infrastructure on which the application is running. And you always need to account for the fact that you will miss some vulnerabilities at some stage of the process, right? So no matter what, you need to do some static analysis and identify vulnerabilities there and detect them. You will need to do some dynamic analysis of the artifacts you produce. You need to do your software composition analysis for open source tools. Once you build your containers, you want to inspect those for vulnerabilities in libraries that could exist. And any tool will have false positive, false negative. So some analysts say that you need, in order to have a complete application security program, I think that's maybe ambitious. But when I talk to our customers, they often have 5 to 7 tools and multiple tools in each of the categories, right? So I think that getting everything as good as the tools can be and as great of a job a vendor can have done with a tool or a suite of tools, I think it's important to have multiples in order to identify as many vulnerabilities as possible. But then that also implies that your problem of figuring out what's important and what to focus on becomes more complex because you have more vulnerabilities. Some of those tools are very chatty, right? So we also think that it's important. I think it's important to have a process where you can really deduplicate and refine those issues into those that are relevant and really triage them based on business risk, based on ease of exploit. But in my opinion, the key things is have enough tools that will guarantee the coverage that you need, and then orchestrate them throughout your entire CI/CD pipeline so that you have continuous visibility throughout your development cycle up to the moment you push in production. Then you have a chance of really ensuring the security of your applications.
And I think that there is a market reality also. There is not a single vendor in the market who has everything for security. This has been evident in infrastructure security, that has been evident into application security, that has been evident in the tools, because this market is too broad and very fragmented. I think that what CISOs and CIOs really focusing on that, not to find a single vendor. How do I reduce the number of vendors in my security footprint? The previous studies have shown that typical large Fortune 500 organization have more than 50 security vendors overall. If they're reduced to 5 or 10, they are much more manageable. And there are a lot of benefits of having a less number of vendors. First is the simplicity. No more fragmented solution, reduced operational overheads, more operational consistency. It also helps in a simplified licensing, less finger pointing, is consistent UX and learning, consistent threat intelligence, which is a huge part into that. I think having a single vendor is a pipe dream. I don't think that exists a single vendor. It won't be there for next 5 or 10 years at least. But if I can reduce my security vendors from by half or by 30%, that itself is a huge achievement for any IT organization, because more and more consistent security posture, more need for agility and speed. That will be driven by less number of vendors, and that's the reason every vendor is moving into an adjacent market so they can offer a better and bigger solution.
I think it's fair to point out that less products is always a good idea, and you can't get to one or even two or three because just fundamentally nobody covers everything. But I think the criteria for which products you pick has become much more focused on how well does it get along with other tools? How easy is this for me to integrate? Because the huge overhead between having many products, except for legal and purchasing, but frankly, everybody kind of puts them aside. The overhead is getting them to talk to each other and work with each other. So the decision criteria becomes, which tools can I make work with my other tools?
That's something we've been thinking about a lot, and we like to think about sort of abstracting out security as its own layer, so that you've got your process that runs along your pipelines, and then you've got a security layer, and you just sort of lightly couple these things. So it's like event driven, like, okay, a developer did a pull request, go do the security thing. And then your security layer just takes care of that. It's got its own integrations to whatever tools that you have from one vendor, from multiple vendors, whatever. You don't care. You just tell it to do the security stuff. And based on an embedded policy or something, it goes and does it. And so if you can sort of make that extra layer of integration, it's going to simplify things and allow you to swap tools in and out, and add tools and whatever.
That reminds me of a great conversation with CISO. When we were meeting with the CISO, he said, Pankaj, you spent 10 minutes on presentation, what your product does. You spend 20 minutes, how it fits in my environment today.
Totally right, and I think one important aspect to remember is security has always been defense in depth, and it's as we talked about, right? And there isn't practically possible to catch all vulnerabilities irrespective of the number of tools there are, right? And it's more important to have the investments covered the key parts of the spectrum, the entire life cycle of code, not just focused on the application security testing aspects, but the entire spread, and picking the best of breed that works well within the environment, like some of our other panelists pointed out. But this is as an emerging problem, right? And in many of these areas, and we talked about edge computing, API security as early areas that are really emerging, right? And aspects of the OWASP top 10 as well, right? That we all want to address are still being worked on. So that's where I think from what we see from our customers, there's increased emphasis on focusing on specific set of problems and finding the best of breed for that, right? And while trying to reduce the number of vendors, but at the same time realizing that this is the world of innovation, this is the world of tech, where it's not enough to solve like the 10% of the problem, right? It is still not really helping their case by reducing risk, right? It's important to meet a high bar with respect to right, the different layers that are required to reduce the risk sufficiently. So and that's where the emphasis has been.
And in a way, I think this whole discussion is really incredibly hopeful in a way, because there are plenty of organizations out there who are just like, hey, maybe this software security thing's important, and they're just buying their first tool, but this whole discussion about integrations is really an indication that there are lots of organizations out there who are moving to multiple tools, and then they're going to the next problem, which is how do I do my integrations and not lose my mind. And so I think it's really a very good sign, and it's a great problem to be having right now.
That's true. That's very true. Another bad problem that we're having right now is we have 2 minutes to the top of the hour. So unfortunately, we need to end our conversation. I tell you, these can always, every single one of these, I always say, we need at least an hour and a half to have these conversations, and possibly even longer. But I think we did a great job on touching on what I think are the high points. But would love to hear feedback from the audience if you have thoughts on additional topics when it comes to managing the application security tool stack, we would love to hear it. But unfortunately, we don't have time for the questions. But please know that everybody who was involved in today's conversation here will be getting a copy of all of the questions that came in. So I'm sure somebody from the organization will be more than happy to follow up with you. Also want to remind the audience real quick that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the Security Boulevard website. So you can always go look for it there. Just go to securityboulevard.com/webinars, look in the on-demand section, and it will be right there waiting for you. Okay, real quick, we're at the top of the hour, but I have to do the drawing for the 4 $25 Amazon gift cards. So please hold on here, guys. First winner today is Alex B. Congratulations, Alex. Our second winner is Ben H. Congratulations, Ben. Our third winner today is Jennifer C. Congratulations, Jennifer. And our final winner today is Victoria G. Congratulations, Victoria. We'll be following up with you guys offline via email to get your gift cards over to you. Jeff, Prakash, Christian, Pankaj, Jonathan, and Alfred, thank you all so much for your time and your expertise. I love having these conversations, and I am so glad you guys were a part of it. So thank you again for just everything for this webinar. You guys made it happen, and I appreciate that. Thanks so much.
Thank you.
Thank you.
Thank you.
All right. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.